Hey everybody, welcome back to the 64th episode of Taps and Patience. I am AJ with Audacity Micro, here with Harrison from Precision Ingenuity.
How we doing?
Good. I forgot to say hi, Harrison. How are you doing? Because I was trying to find the button to turn off the music, but
That's all right.
we can't ever have a perfect intro. It's the rule.
Well, it's funny because every time you say Audacity Micro, I always look at you're always wearing a Design the Everything shirt or hoodie or something.
It's kind of cold in my shop right now. Well, one, it's cold outside, and two, earlier today I was cutting up a full length bar, and the bar was like 250 pounds, and so I was not going to be easily maneuvering that by myself. And so what I did is I moved the saw to the door, which is something I've been meaning to do for a while. And it just happens to work out that the height of my saw is pretty close to the level of the bed of my truck. And so I slid it straight out of my truck onto the saw, cut a couple pieces off until the bar got shorter, and then lifted up the bar and drove the truck out from underneath it and put it on one of those little rolly stands, and then continued to cut the bar.
So what do you need a large bar for? I mean, I thought your whole deal now was like small stuff.
I know, right? So I'm doing a run of parts. It's basically a I was gonna say it's a Pringle, but it only has one. It's like a section of a cylinder.
Okay.
Like take a tube, cut that tube into fifths or something, and that's what it is. They're like 5 inches long, and they fit into a 3/4 inch bar. Stainless, and they're 5 or 6 inches wide.
So is this for a Xometry job, or is this?
Yes.
It is a Xometry job.
Yep.
Oh my.
So it's a really simple part. Like it is basically like just the section of a wall of a tube. There's some slightly odd bevels on the ends, but the reason I took this one is it's basically all surfacing.
Okay.
Which my high RPM spindle can do well. Though I'm thinking about running it in the Tormach, actually.
Okay. So I heard, or I didn't hear. I'm trying to figure out. You still have your Tormach, but...
I still have my Tormach. I was talking to somebody about selling it, and the reason that's not a done deal yet is because of the financing with Geneva Capital. Okay. The way that the guy wanted to buy the machine through Geneva Capital or like transfer the lease, but I don't like how Geneva Capital, I don't like their terms of how Geneva Capital does that.
Okay.
And so in order to sell it, what I would have to do is actually buy out the rest of the lease with Geneva Capital.
Okay.
And then, so I would buy out the lease, and then he would get financing through Geneva. Geneva would then just pay me money. So I would pay Geneva money. He would get the lease. Geneva would pay me money.
Okay.
And it just involved a lot of runaround. And at this point, I'm not sure if it's worth the effort because like the Tormach's still making money. So it's not, I don't know. I may not sell that machine.
Oh, okay. I was wondering if you were still planning on holding on to it or not.
Yeah. I kind of put up a listing for it with a like, this would be a pretty nice price for it, expecting no one to take it. And then I got a couple bites. But at this point, like today, both machines ran for a large portion of the day. The Haas ran for probably 6 hours, and the Tormach for probably 4 hours. And if I had been on it more, the Tormach could have easily run 8 hours today.
Yeah.
I should probably start it overnight, actually. So it's still getting used. And while I like the idea of having another OM, I do also plan on upgrading from the OM at some point. And so I'm just afraid of doing like a half step and selling the Tormach, spending however many hours it takes to get that machine out of here and to the new buyer. And then paying freight for the OM to get here and, going through the loan process, getting the OM here, paying freight for it to get here. And then turning around and selling it again, and again, freighting it off, like finding a new buyer for that machine, freighting it off, and then, paying freight again for another machine to come back to me. It's it's like, and maybe we just skip the middle step and go to whatever I would get after the OM.
So have you thought about that? You seem to at least have thought that your OM is not the end all machine. So
Well, don't get me wrong, I love that machine and I would take a second one. I think it would be a CM with a 5th axis drive or something along those lines.
Gotcha.
The CM is just the OM.
Yeah, I gotcha.
But I think I would like 5 axis if I can.
Well,
maybe we go solo.
I was gonna say, did you get the email today?
I glanced at it. I didn't see any new details, but I didn't read it. So
well, they officially launched it. You can request quoting and go to their website and actually see information on it. I actually just looked at that right before I got on with you.
If that machine can hold the tolerances that I'm going for, I don't see why I wouldn't have that at the top of my list.
Well, their base price they have them asking right now is $80 for the base machine, and then they have all the different extra stuff you can add on from there.
Yeah, but that's not too wildly different than a well-outfitted CM.
Yeah.
So again, and the pocket ends or the Solo, which is not actually a pocket NC anymore, but the Penta Machine Co. Solo actually has a lot more of the accuracy stuff built into it than the CM does. So theoretically, if they did everything right, the bones are there for a more precise machine.
Yeah. Well, it's interesting because the way they've done it, and I've never seen this from any machine builder, is that when you go to request your quote, they kind of give you the pricing of everything, so it's kind of upfront pricing. So I don't understand why you have to get it quoted as well.
Because they want your email address.
Yeah. But one thing that's interesting is they have 3 levels of precision for their packages.
Oh, really?
Mm-hmm.
That's interesting.
And so, depending on the precision you want them, and I don't fully understand it. I definitely have to talk to a salesperson, to fully understand what it is. But they call out a 6/10, a 4/10, and a 2/10.
Okay.
Package. And so, and I don't know if that's just if that's like the accuracy that it can hold, if it's the accuracy it's constructed to. And so it's just kind of interesting. And it goes up pretty substantial with each package. So
yeah. So the base one, they say 6/10 inches flatness and squareness.
Mm-hmm.
And then it's 4/10 and 2/10. The 4/10 is $7,500 more. The 2/10 is $15,000 more.
Yeah.
And it says the base price is $80K. So gosh, you could pretty easily spend $100K on the Solo.
Uh-huh. Yeah. So it's getting up there. It's getting up there. So it all depends on the size of parts you want to run. If you're going to stick with small stuff, it could be a fantastic little machine.
Well, here's the thing: the 5-axis, what's it called, CM, would be a smaller work area.
Yeah, because I think it's only is it a 2 or 3 inch cylinder that's like 2 or 3
it's
three
tiny,
or 4.
Yeah, it's something like that. I think they call it, it's like a TRT 70, so I assume it's 70 millimeters.
Yeah, it's 70 millimeter platter, but I think the part can be bigger than that. But that's I don't know by how much.
True.
I don't know by how much.
I suppose it depends on the size and shape of the part. I mean, if you had a like a muffin where it had a smaller base and a big head, like as long as you didn't need to rotate it to where it had to clear the trunnion, I mean, it would still have the normal 7x10 or whatever they are work envelope.
Yep.
I would totally try this machine.
So
it's expensive though.
It is expensive. It's a cool machine though. I mean, it's close enough in price to, like, if you fully decked it out, to like the entry level price of like Haas's weird UMC 350. Like the UMC 350 now, they have it as an EDU. They moved it down from the main line to the EDU line, and I think it starts out at like around 80, like at the same price, and it's got a much bigger part capacity.
Yes. Is it really that cheap? Gosh.
Yeah.
The only problem is it still doesn't fit in my shop. So, me moving shops would be, gosh, conservatively what would put me at $1,000 a month or something more.
Probably, at least.
And
you got other problems you got to deal with before you get to there.
Yeah, I know. I mean, a new machine for me would still be at least a year out. So
yeah, but I still like the idea of you having an OM and then a Tormach replacement, something that's a little bit larger that can take on. Because I like the idea of doing your small stuff with the OMs, and I definitely think there is a niche there, but there is still parts that would have features that would be great for the OM, but you'd still want to do the bulk work on a different machine. Or if you want to continue in the product space or offer capabilities to as a normal job shop outside of Xometry, having a larger machine, I mean, larger relative to the OM. Like we could talk, mini mill or, something along those lines. It doesn't have to be a big machine.
Yeah.
Just bigger than the OMs would be pretty big for you.
Yeah. I did consider a super mini mill or something. I think I haven't checked to see if the new ones will fit in here. I bet they don't, but at least the regular mini mills do. And now you can get a bigger tool changer on them.
Yeah. Yeah, which is nice. And I actually went back in the Wayback Machine to kind of look at the old Haas offerings for the mini mills. And what they did is they had the mini mill 1 and then the mini mill 2 and the super 1 and the super 2, and they kind of they made a new machine that was larger than the mini mill 1 but smaller than the mini mill 2.
Oh, really? That again would actually be perfect for me.
So they basically split the difference. But the one thing they did do is they added 2 more inches in Z across the board, I believe.
Oh, which would actually hurt me.
No, I mean, it would be 2 more inches in Z.
That means the machine's probably 2 inches taller.
Oh, that or the bed's 2 inches lower, which would be nice because the bed was pretty high on that machine.
That would be nice.
Because I think they redid the castings and whatnot, and if they lowered the bed by 2 inches,
that could be.
Then I would be all for that.
So now we're back to internet browsing on a podcast, and we've barely started. I'm trying to find the chart that has the shipping dimensions on it. There we go, technical documents. Not that I'm buying a machine anytime soon. Anyway, while I'm distracted, I'm going to give you a question so you can talk while I'm distracted.
Okay.
We got a question about what our workflows are like. I think the question was mostly centered around CAM, but let's just go through the whole process. So you get a part, you get a PO, they give you a CAD model, go from there on.
So right now, and this is something that me and Weston have been dealing with a lot because we really want to go with an ERP system at some point. And so we're trying to structure our system like we're trying to be the manual ERP. And so right now we're putting everything into monday.com and that's where we create all of our job numbers that are floating around in the shop. And so that's where job number assignment is created. From there, we create a folder in our OneDrive that has the same job number and description that's in Monday. And from there, pretty much everything happens in OneDrive. Monday is just kind of a top-level view of everything that's in the shop and its due dates. It's just kind of a high-level picture of everything that's going on. From there, we put all of the customer documents and information into OneDrive, and then we'll import everything into Fusion, and we'll use the same job number once again. When it comes to programming parts, we don't have big templates right now that you can just load a part in and all of the stuff is pre-programmed, or 80% there or something. That is an area that we would like to get to, but we're still refining how we're creating tool paths. And with the new machine that's coming in, I'm sure there's going to be a lot of changes, especially whenever we are able to do some 5-axis stuff. And so kind of want to get a good feel for how to program things. And right now we are taking a lot of extra steps because we have a Tormach, and just because you have to take a smaller bite or extra semi-finishing and finishing passes to get the dimensions on size and the quality that we're trying to aim for, that I don't really want to build that into any templates for long term. So I just haven't put forth the effort into that side of things. But programming typically takes anywhere from 10 minutes up to an hour per part, maybe an hour and a half for something complex, especially if I have to develop any kind of soft jaws um, or any kind of special fixturing to hold it. And then from there, we'll print everything out. And then one of the cool things that we just started doing is we have one of those thermal printers, like a Rolio thermal printer. And so we got some smaller stickers and we printed out on it all the information that you would want kind of in an ERP system. So it's got it's just a blank sheet and it'll have, job number here. Oh, what all does it have? It has job number, it has material cost, it has quantity, it has due date, it'll have, saw cut time, op 1, op 2, op 3, op 4, mill lathe. And what we have is we just have an M or an L. So you just circle, was op 1 done on a mill or a lathe? How much time did it take? We have, deburr, finishing, laser marking. And so basically we're tracking, we have a sticker that we can stick on the print. When the customer sends us a print, we print it out and then we put that sticker on there and we just fill out the sticker with all the information on that part. And then at the end of the job, we take that part and we enter it into our sheet where we figure out where it spits out a price. Or on the flip side, say someone gives us a part to quote, we'll do all the steps that I said, except we'll go into the accounting folder that's created whenever we create the job, and we'll go down to an Excel sheet and we'll fill out all the information on how long we think it's going to take to make the part. How long is it going to take to mill it? How long is it going to take to program it? How long is it going to take for saw, finish, if it needs to be sandblasted, laser barked, inspected, shipped? What's the material going to cost? Is there any specialty tooling? Is there going to be a water jet? Like, do we need to use a water jet or laser cut parts? Is there going to be welding? There's all these different questions that we have built into our quote sheet. And then at the end, if we pre-quoted it and we got the job, we still fill out the stuff on the print, and then we compare the two and we see how close we were to the quote. And so, like, I had one the other day where I quoted a part at $69, and then we ran all the information on the sheet, and it came out at exactly $69. Nice. So, like, it was like really good. But then I also had another one where I quoted it way too cheap, and we came out like 30%. It took us 30% longer than what I had quoted, or something like that. And so, like, we're still kind of learning that, but we're trying to, anytime we quote, we're trying to actually track the time that it actually takes to get the part done to see how accurate our quote was. And then from there, once the part's created, or once the part's been machined, then it'll be inspected, and if it gets shipped out, we go to the packaging place, package it up, ship it out. If it's a local customer, we have a cart or a shelf of parts that, as they get finished, they just accumulate on there. And then whenever we go make a delivery, we'll grab all the parts off that shelf and pack them up and ship them out.
So I guess my workflow isn't that different overall, with a couple little tweaks. First of all, I do have those CAM templates developed now. So I get my files. At this point, they're all coming from Xometry pretty much. I get my Xometry files. I drop the CAD file into one of my templates. That CAD template has a place for both op 1 and op 2. And basically, I just put it in the right place. I type in the size of the stock. I mate the part into the stock, and I hit generate. And it gets me like 75% of the way to a finished part on like 75% of parts. Sometimes I drop a part in there and I don't have to do any manual CAD work or CAM work. It just works. Sometimes I have to completely do it by hand. So, for example, those peak parts that I was fighting last week, I think the op 1 and the op 2s got me maybe 10% of the way. Like, the templates got me maybe 10% of the way. So they're not perfect, but they sometimes can save me a bunch of work.
Yeah.
But I have my table modeled up in Fusion. So like the
Mm-hmm.
Flux Vice is there, my Mod Vice is there. The I have a parametric chunk of stock that's in the Mod Vices. And the first thing I do is I go and I open my parameters menu and type in the size of that stock, and that will actually shift the Mod Vices on the table. So if I'm ever really on it, I can actually figure out what holes I need to put the Mod Vice in, which is nice. I don't think I've ever actually done that, but in theory, I could. And it also has a template now to do my soft jaws for me. So
Okay.
the way I tend to do those is I just mate the part into my Flux Vice model, and then I use the combine function to subtract the model from the jaws, and then I clean up any errant faces, just generally using the delete button. Sometimes, obviously, I have to actually like do a real model of those, but for the most part, just combining the model with the soft jaws gets me close enough. And then my cam templates are set up where I pretty much never have to do any custom coding for soft jaws. So that's been
Gotcha.
very nice. After that, actually before that, I print off a traveler for each job. That traveler goes into a bin that I have. All of my jobs get their own bin. I call them Kanbans. I don't think it's technically a Kanban. It's more of just a physical traveler than anything else. But inside that bin, I put any special tooling that goes with that job, all the drawings, any material certifications, like anything that is specific to that job goes into that bin. Any stock or like setup parts, soft jaws, they all live in that bin for the duration of the job. And let's see, then I set up tools, I run the part and inspect it just like you'd expect and ship it. At this point, I don't set up too many tools per job, which is really nice. I currently have, I think, 8 core tools in the machine. I'm probably going to expand that to 12 and then call it good. And those tools cover a large portion of everything I do. It's not normal for me to set up more than probably 3 tools per job. So that has saved me a lot of time recently.
Yeah.
Yeah, I mean, that's pretty much my workflow. It's fill out the inspection report, do a drawing, package them up, send them to customer. That's all pretty
Yeah.
standard from there.
It sounded like that question was a little more directed at Cam,
I
and I
think it
realized
was. Yeah.
and I realized I probably wasn't super good on the Cam's explanation, so I'll try to go into a little more detail, at least on my thought process for Cam.
Okay.
So for my thought process at Cam, everything's pretty much focused around work holding. That's kind of what drives my thought process more than anything else. And what I try to do is I try to one limit my ops, and if I can't limit my ops, I simultaneously try to limit my ops and limit the need for custom fixturing.
Okay.
And so if I can orient my part in such a way where I don't need custom fixturing, that'll override any desire to reduce the amount of ops I take. So if I can add an extra op, but I don't have to create a set of soft jaws or some sort of special fixturing, I will do those extra ops to save on work holding time.
That's an interesting difference between us because at this point, I do not try to reduce I do not try to reduce soft jaws at all. I just accept it's built into my quoting. Every job will use at least one pair of soft jaws.
Yeah.
Even if I was doing a rectangle for the like if I was just doing a prismatic rectangle, I would probably still do it in soft jaws.
Yeah.
Because I don't have my probe right now, and if I cut the soft jaws in situ, I know
Mm-hmm.
they're going to be basically perfect.
Yep. Yep.
And it's just one less thing for me to think about, and there's very little overhead for me because that part is like the most automated part of my workflow.
Mm-hmm. So
So
for us, we have the two manual vices. We have a 5-inch vice and a 6-inch vice, and we have to remove 4 bolts anytime we want to change them from hard jaws to soft
yeah.
jaws. And so for us, it is way more faster and efficient to generate an extra op than to change out those jaws and program a set of soft jaws. Just the way our workflow works out. And what we try to do with our programming as well is I try to set it up where my jaw 1 is op 1 and my jaw 2 is op 2. So we try to flow parts through as much as possible. Yeah. And so if I have a 6 op part, I'll do op 1, op 2, op 3, op 4, op 5, op 6. I'll try to combine them like that, where I'm doing 2 ops and 2 jaws and 2 different vices, and I'm flowing everything through. And that has been a winning strategy in terms of flow throughput for our current process right now. So yeah,
I made a work holding investment. I don't remember when this was, but I think it was after we did our last episode. I bought one of those Chinese self-centering vices to replace my mod vice.
Oh, really?
Yeah. I did not get the super small ones. They have a bigger one.
Okay.
I think it's 110 millimeters wide, which is like what, 4 or 5 inches, something like that.
Mm-hmm.
And it'll hold, I think, 180 millimeters. Maybe it's like 90 millimeters wide and it'll hold 110 millimeters. I don't know. It's something like that. Basically, it's big enough to hold 100% of my parts. The little ones were just big enough to hold probably like 75% of my parts, which would have been really frustrating 25% of the time. And so I was like, instead of spending $60 on one of the tiny ones, I think it was $180 delivered.
Okay.
For one of the bigger ones. That being said, it has not been delivered. So at this point, it's all
okay,
hopes and dreams. But
speaking of vices and whatnot, we did get a small 5-inch self-centering vice for our 5-axis. Mm-hmm. But in addition to that, some of the tooling for our that came with our Haas machine, some of it showed up last week. So we've got some boxes of tooling. It's not everything, but the vice came. And I want to say like some, it was the vice and it was like the T-nut kit that everyone gets to bolt stuff directly to the table. That we already had one from the Tormach, and I'm pretty sure it's the same kit. Like whatever company makes that kit, they've sold it to everyone.
Yes.
But so anyways,
just some got one of those. To tease you.
Yeah, so we still haven't got we got like 20 tool holders, and so those still haven't showed up. Those might show up with the machine whenever they deliver that. I'm not sure.
Not going to do you any good before then anyway, so.
Not going to do us any good before then, but it was just kind of funny to see like these big Haas boxes show up, and we're just like, oh, what's that? So, looking forward to that greatly.
But I need more 1/8-inch collets. I almost ordered some from Haas the other day, but they're back ordered until like March. For the size I need. It's like that's not what I want.
So can I rip on the Tormach a little bit? Yeah. Okay. I have a complaint with the Tormach right now. And I don't know what's causing it. It's really weird. I'm machining a 15, almost 16-inch wide plate.
Okay.
That's about 9 inches tall. So it's like a 16 by 9.
Oh,
roughly.
I was like, I was thinking 9 inches thick, and I was like, oh my gosh, that's a big piece.
No. It's only a quarter inch thick.
Okay,
it's only a quarter inch thick. But I'm facing it, and I was facing it with a 2-inch face mill, but it kind of left kind of like a ridgy feel, and so I decided to face it with a 1/4 inch end mill, just because I needed it to be a perfectly flat surface. They called out for a perfectly smooth surface, and for 70% of my plate on the left-hand side, it is perfect. It's perfectly flat. You can run a fingernail across it. You can't feel anything. The last 30% on the right-hand side is rough and ridgy, like really bad. And so I converted my end mill to go 90 degrees to that and to reface it. And it cleaned it off, but it took off the peaks, but there's still valleys that it didn't touch. And so this has been consistent on 3 or 4 different jobs. That side of the machine, when it's hanging all off on one end, there is a huge difference in Z height until it gets towards the middle of the machine, and then on the opposite end of the machine, when everything's the other way, it's fine.
So where?
But I don't use that side of the machine that much. I use the side that's smooth, like the middle, more than I use that side. And so it's just weird.
I mean, it still sounds like where.
I mean, it could be.
Even if, like, this side is worn in, so that side is binding, or something weird like that.
Yeah, I don't know. But I machined about 4 inches out of those 15 inches at 90 degrees, and towards the end of that, it would kind of cleared up. So it's about 4 inches of that 16 inches on the right-hand side.
This may be a dumb question, but have you tried tightening your Gibbs?
I did all that like 3 months ago.
Oh.
I haven't done it.
That might be worth doing it again.
It might be worth doing it again, and we've talked about that. So that might be what I have to do. But it's just kind of getting to the point now where things on the Tormach are starting to fall apart faster than we can put them back together, and we're losing motivation to fix them.
Yeah.
Because we got a new machine coming. And it's not the Tormach's fault. So for anyone who's listening, I am not poo-pooing Tormach, okay? We are running this Tormach like 70 hours a week sometimes, and they're not small, simple jobs. These are like big parts. I think I sent a picture to you, AJ, of like some of the aluminum parts we were running. Like these parts are like the part I think I sent you a picture to you. It was like 11 inches by 8 inches by like 3/8 of an inch thick aluminum plates.
Yeah, it's like the size of a textbook.
Yeah.
Except a little bit thinner, but depending on your subject.
Yeah, and so for a Tormach, that's, 60% of the work area at least. And so that's like a relatively large part, and we're running them, large quantities of them to the point where we're having to empty the chip tray out about every 3 to 4 hours. So the machine just it wasn't built to maintain that for 70 hours a week.
Yep. I emptied my chip tray last week.
So
on the Haas, not the Tormach. I still have another probably 6 weeks on the Tormach.
But I'm still very proud of that machine. I'm amazed at what we've been able to run on it. But it is starting to deteriorate. At least it feels like it's starting to deteriorate, or we're just becoming more picky at a faster rate, just because of how hard we've been pushing it, especially in the last 4 months or so. Just because we've just like the amount of work we've been pushing through the shop has just increased in the last 4 months, like 3 or 4 times. So that machine just is struggling.
Yep, you need your VF.
Yeah, I do desperately.
Are you going to put fixture plates on that thing?
I'm not sure.
Okay.
Go ahead.
I was just going to say, I sent you the Saunders discounted fixture plates from Saunders because I saw them.
Yeah. I need to go look at what their pricing is on those. I hadn't clicked on the link yet.
I don't think it's a whole lot cheaper, but it's at least a little bit cheaper.
Yeah. It's definitely... me and Weston have talked about it. I think we're going to start off with just going off of the table to start. But the fixture, if we do any plate work, it's going to make it a lot more sense to have it on a fixture table like that. And so it just kind of depends on how big a plate work we do. But at the same time, if we get a couple vices, like even the large parts that we do on the Tormach, if we had 2 or 3 6-inch vices that were all parallel, you could clamp on them, a larger part across all the vices and be fine most of the time. So, not sure what route we want to go on those. But I could see a fixture plate in our future, especially if we're going to be taking the 5-axis trunnion on and off. I want to come up with a solution for that, and I'm not sure I trust the Saunders table for that particular application. That might be a little bit much for it to handle, unless it's like this. Like I know the aluminum. If it was an aluminum fixture table like what we have on our Tormach right now, I would not trust the aluminum fixture table to repeat with any kind of accuracy with a 300-pound trunnion table. trunnion. So
it'd probably work for a couple of times, but
yeah,
then you're going to wear it out.
Yeah, so definitely need to do something steel or stainless or something to if we're going to do a fixture table or fixture table on the top. So we're still trying to figure out what we want to do there, and we might just need to use the machine for a little while and just figure out what makes the most sense.
Yeah. For me, the reason I wanted the fixture plate on my machine from day one is all of the work holding I had on day one was Saunders Machine Works, either the not the flux vices, the mod vices, or the pallets that I already had. So, yep. Like, in order to run on day one, I basically needed that fixture plate.
Yep.
Now, I won't be running any mod vices. I will have that self-centering vice, and I have my flux vice. So, not super necessary there.
Yep. Yeah,
it is nice that the flux vice is fixture plate compatible. That is very nice.
One of them.
Yes,
you got two now. So
I do.
Are you pretty much using those two exclusively now, or are you still using the mod vices?
So my original plan was to put both flux vices in the OM, and that would have worked. That would have been fine. However, I realized that I wasn't going to gain very much with the other flux vice in the OM over the self-centering vice. Like, I would basically use it the same way, and I needed the flux vice on the Tormach. So what I ended up doing is I used to have two pallet positions set up on my Tormach. I merged those into the same position because I was just swapping them on and off anyway. I was never using them side by side. So I merged my pallet positions to be one pallet position, and then I put the flux vice as a second station next to it.
Okay.
And that lets me leave the fidget cubes set up that I have been running painfully slowly in the background. But I have been running. So
that's good. Would those fidget cubes almost seem like the perfect thing to stick into the flux work holding vice?
Yes. Yeah, so that's what I'm using it.
That's what you're using for? Okay.
Yeah. Yeah, okay. So I have it set up with 4 stations. I might have been able to get 6 stations in there if I tried really hard, but 4 stations at the moment. The only problem is my script, which automatically posts the code, is broken. And I think it's Fusion's fault. Because I went back and I tested a different program I had, and that one also didn't work. So it's possible that something weird happened on my computer, or with my post maybe. I haven't gone too far down that rabbit hole, but I've been having to manually post out the code, and it's been really annoying.
Yeah.
So that's one of the reasons why I haven't been running them faster, is because I have to manually post the program every time.
Yeah, that's annoying. Fusion is awesome because of how much they update, but it can also be annoying with how much they update.
Yeah, especially when it breaks your existing programs.
Yep. I
will say, so one of the things I was worried about was if there would be a surface finish difference between the Haas and the Tormach, because I ran some of them on the Haas and some of them on the Tormach. I changed my feed per tooth to be exactly the same as it was on the Haas, and I'm using the exact same tool. I took it out of the Haas and put it in the Tormach, and they are indistinguishable. So,
that's good.
If anything, I think the Tormach might actually give me better finishes. In there was one little area of the cube, like on the top left corner, where the coolant was being shielded by the tool and by the cube itself, kind of like 3/4 off the edge of the corner there. And because the Tormach has a coolant ring, I'm getting better finishes on that corner.
Gotcha. So,
now it's running, I think, 4 times slower. I think before 4 cubes was taking under 4 minutes, and now 4 cubes are taking 12 minutes.
Gotcha.
But I mean, they're running, and before they weren't running, so yeah, that's still a win.
Well, a machine running slow is better than a fast machine sitting still.
Yeah, exactly.
So,
or doing something else.
Yeah. And so that's what me and Weston have been talking about recently. It's like I will take a reliable hands-off program over something that I have to babysit hands down pretty much every single time. And that's the mindset we need to have going into automation. It's not a speed game as much as it is a reliability game. That said, I still like to push the reliability. Like, I still want to push the limits of what's makes sense, but then dial it back to something that's a known safe. So I'll give you an example. The part that we're running right now, we have 6 parts, and it's that 15 or 16 by 9-inch plate. The very top of that plate has like 6 1/16 inch wide grooves that are the full length of the part. Mm-hmm. So it's a lot of slotting with a 1/16 inch end mill.
It's massive though.
Huh?
Huge end mill. Huge end mill.
For you, maybe. for us, that's a baby end mill. Yeah. But, we did a little test where we bought a whole bunch of them because we knew we were going to be breaking them left, right, and center. But we started out with Haas's recommended, which was 80% of its recommended feeds and speeds for side milling, feed per tooth. And we ended up, that would run me about 3 slots before the tool would break. Then I dropped it down to 70%, and that would run 90% of one part. And then we dropped it down to 60%, and that one ran 2.5 parts on one tool before it broke.
What material did you say it was?
304L.
Okay.
With a 1/16 inch slot. That was 1/32 inch depth.
Okay, so you were probably just running full depth of cut?
Full depth of cut.
Okay.
Yeah, one pass.
I know it's too late for this, but the Kyocera, well, they're not Kyocera, they're SGS. Their 3-flute is really good for slotting in stainless.
Mm-hmm.
I was doing my coins with that tool, and those, well, you made the blanks. Those are 304, right?
Those are 303. Well, it depends on which coins you got, because
they were the first batch.
The first batch was 304. Everything that's been done now is 303, but the first batch was 304.
So yeah, those were 304 stainless. I think I was slotting a 16th deep.
Okay.
And I tried like 6 different tools, and I found out the Kyocera 3-flute coated end mills were the best for slotting.
Okay.
And
this one,
I was getting tool lives of like 12 minutes with the Lakeshore ones, and the Kyocera ones lasted me like hours.
Yeah, so if you were to equate that to a tool life, the slotting at 60% is a 10 minutes per part. So I was getting about 25 minutes to 30 minutes of tool life at 60%. What it normally recommended. So yeah.
I was also plunging with the end mills to get to like the middle of the engraving with the coins.
I'm coming in from the side, so that helps.
The one problem I had with those end mills, it was the most bizarre problem I've ever seen. It's because I was plunging, I would get birds nesting on them, which you never see on end mills. With drills, sure, but this was the first time I'd ever seen bird nesting on end mills. And it's because they would plunge down, a 16th of an inch. 30 or 50 times in the course of one coin.
So that's kind of cool, though, that you're plunging with the 16th inch end mill and stainless.
Yeah. So I was going slow, but I mean, it did it.
But regardless, we've gone through several of those end mills, but it's just been kind of interesting to kind of experiment with feeds and speeds. And this is a 4-flute. It's probably not. It's not really designed for slotting. That's not really what we use it for. But it's the one we use it for, and on the Haas website, it's like, I don't know, like $10. So it's kind of like, it's kind of one of those where we're not going to buy something special. We're just going to throw tools at it just to get it done, just to get through this job. If we did a lot of it, we definitely would probably be looking more towards special tooling for that.
I have broken 5 tools on my Haas. 3 of them were today.
Oh, really?
Yeah. The first 2 were 20 thou end mills that I was using for slotting. And I mean, those just broke because small tool problems. Then I broke a 3/16 end mill today because I jogged the wrong way. That was frustrating.
Ooh.
Yeah, my kids came in the room and distracted me, and I was trying to do multiple things, and I zigged when I should have zagged, and that made a nice, satisfying, crunching, popping sound.
Yep.
And then I was doing some features that were some like kind of, I keep calling them microfluidics channels. I think I'm actually like an order of magnitude to be called too big to be calling them microfluidics. They're like mini fluidics. But anyway, there's some little fluid channels in this part that I was surfacing in with a 1/32 inch ball mill. And I actually, it may be fixed and done right now on my machine. We're back to Schrodinger's end mill here. But I think it was my tool path.
Okay.
And I went back and I revised my strategy. I was using a scallop, I think it was, and I turned my scallop into a contour. And I'm hoping that's fixed it. But that was
with those small end mills, any material that is not in the location the program thinks it is will break them.
Yes, exactly. And I think the way that the scallop was working, I think it was ramping downward with the ball mill, and ball mills don't like to cut down, they like to cut up.
Yeah.
So the contour, I think, did it the other way around.
Yeah.
So I don't know. I can run off during the outro and check if there's a tool there still.
Yeah. Yeah. But man, I had something I was going to say while you were speaking of all that, but I can't remember it now.
I had a cool thing. I did a cool setup during this part. I can talk while you're thinking, though it sounds like you thought it. So anyway, this part, it was a cylinder. There's two NPT fittings on the back side, and then on the front side, there's the fluid channels. And so the NPT fittings had to be fairly precisely clocked to the fluid channels. But because the parts were just cylinders, there was no way to index them. I was proud of myself for this one on how I did it. I needed to make two parts, just two of them. So what I did is I made them out of just rectangular bar stock, and I made both of them out of the same piece. And so that way, when I flipped them into my soft jaws for Op 2, they were like self-clocking.
Okay.
Because I had the two posts. I was proud of myself for that one. And it worked really well.
That's good. That's what machining is. It's about taking challenges and figuring out how you can use your material and your setups to do complicated things with simple solutions.
Yep.
And I love having a very complicated problem that just drives me mad, and then I come up with a simple solution. I'm like, okay, this was way easier than I thought it was, or I figured out something that just was really complex and made it easy. In either case, I'm happy.
Yeah.
But the thing that I just remembered was something that I did today. So remember when I told you that on that large part, I faced it with my face mill first before I did the end mill? Well, I used the Pearson pallet system with the vacuum table on top. And then on top of the vacuum table, I had one of Pearson's sacrificial top layers. It's like 3/8 of an inch thick that you can machine your own gasket toolpath into, which works phenomenal, by the way. I've used it. We haven't used it at all, and I've used it twice in the last week. And I absolutely love it. It's produced some really amazing parts. It's just expensive. But when I was facing it, the part was so thin that the part was so big that it came right up next to my tool setter. And the face mill would have hit my tool setter. And so I had to come up with a solution where I could use my face mill without hitting my tool setter to try to face the whole part. But it was too close to it. So what I did was I unplugged it, but I left it in the machine, but I used a whole bunch of rubber bands to compress it down to its minimum size. That way the face mill could go over top of it and not hit it. And I thought that was just like it was a really simple solution to a problem, but it made me really happy because I didn't have to disassemble any of my fixturing. I didn't have to do anything. I did use tool brake control on the 1/16 tool when it was done, but I just changed that to a force stop. That way I could just manually inspect it. But that way I could run the whole program. It would just stop at the 1/16th, so I could just see if it was still there and actually didn't break. But it allowed me to run the face tool. That just made me happy. It's just the little things like that where it's just like, oh my goodness, I don't want to move my whole fixture over, and I don't want because with that I have to take the part off. I have to take the Pearson vacuum off of the Pearson base, and then I have to take the base, and then I have to move it over one notch in the Saunders table. And then by moving it over one notch, that might make the face mill, because the part's so big, go out of bounds of my actual work envelope. And so it might cause a different problem.
Yep.
And so it was just like, I was fighting it, and I was just like, well, why not just use a couple of rubber bands? I'll just compress that. Yep. And that solves my issue. So, anyways.
On these cylinder parts, I did something that was kind of fun. I think it was Rob Lockwood who was talking about this, or I don't know, one of the guys that's kind of in that group. There's like Dr. Phil and Rob Lockwood, and it was one of them. Mm-hmm. They were talking about how they would like start a part roughing and then go finish the cam for it. Mm-hmm. And I did that with this part. Is I put it in my template, it generated everything that it was going to generate. I posted that code, I plugged it in the machine, and it was actually a Saturday. So I didn't do the cam while I was running, but it was like this part had a lot of material removal on it, and it was just plug in the machine or plug it into cam, generate the tool pass from the template, hit go. That did like 95% of the material removal, and then I was able to program the last 10% this morning. Mm-hmm. And yeah, that's a nice workflow. I want to, I think, split my template into like, these tool paths will always be safe to run. Put your material in, generate these, hit go. And then I'll have like the second part of my template that's the ones that are a little bit more hands-on.
Yep. I'm greatly looking forward to having 5-axis and developing some like standards like that. Like, we do so many little parts that have so many different setups that it just kills us to not have 5-axis yet. Like, it's going to be game changing for the company.
It would have been really nice for those peak parts that I made the other day, because those were 6 setups.
Oh, was that the disc with the 2?
Yeah, the disc with the 2 fittings on the side.
Yeah, how'd that go?
Not smoothly, but they shipped and they look good enough. They were very poorly designed, I came to realize. So basically they were a quarter, like the US currency, a coin. They had 2 MPT fittings on either side of it, and then there were some microfluidic channels kind of zigzagging down the middle of the part. Mm-hmm. The channels, totally actually the easiest part of the whole thing. And actually, the MPT fittings were pretty easy too. The problem was the hole that connected the fittings to the zigzag. And upon further review and a little bit more contemplation, the wall thickness that they left there was just like between the sides of that hole and the top and the bottom of the coin. Because basically you're drilling into the edge of the coin, was just far, far too small. And what was happening is they had like, I think it was a 5 thou or something clearance between the edge of the hole and the wall. So 5 thou wall thickness. And it was a 30 thou hole. And technically, I had plus or minus 10 thou tolerances on this part. And so technically, if the hole was oversized by 10 thou, there would be no wall there. Or if the part was undersized by 10 thou, there would be no wall there. Or if they were both, there would basically be no part left.
Yeah.
So it was just like a very dumbly toleranced part. Yeah.
Yeah.
And what was happening is one, I had a couple where the drill bit wandered, and so those were just immediately scrapped. But also, I made a couple of them where you could actually see the hole on one side of the part, but not on the other side of the part. Because the material was just a little bit translucent.
Mm-hmm.
And I scrapped a couple of them that were like that until I realized the difference between the ones where you could see the hole and the ones where you couldn't was literally like a thou and a half.
Oh
And
my.
so at the end of the day, I was like, these are in spec. Like they look kind of dumb because their spec is dumb, but
Yeah.
that's not my problem. If they wanted to pay Xometry for a plus or minus 5/10 tolerance on these, I would do it. But they
Yeah.
chose to make the parts cheaper with a big tolerance range. So do you know what? If you can see the edge, or if you can see the hole through the part on one
Mm-hmm.
side but not the other, it's not my problem.
Yeah. There there's definitely times where tolerancing is something that drives me up a wall for how some of these parts are done. Like too tight of tolerancing drives me up a wall, but sometimes too loose of tolerancing is even more annoying because it's like as someone who's designed stuff in the past, I know this is going to fail, and I can
Yeah.
argue until I'm blue in the face that you gave me bad tolerances, and I the parts in spec, but it still annoys me because I don't want to hold myself to a higher standard based off of your lack of adding that in, but at the same time, I don't want to produce a part that I know is not going to work. And so it's like, okay, Zometry quoted this at a plus or minus 5 thou, but the customer is expecting to press a bushing into that.
Yeah.
And so like like okay, we can do it. But
The other part that was on the same order for the same customer had a 0 thickness wall. So it's not like they exactly knew what they were doing. I cheated using the tolerances on that one a little bit. Basically, they had like, just imagine a rectangle that was half an inch thick, and they had a half-inch hole in it. And so,
oh
like in the
my.
CAD model, there was material there, but really it's 0 thickness. And so I moved each wall out, I think 3/1000ths of an inch, so that way the walls were at least 3 thou, and that
Yeah.
worked. But it's like, come on, guys, 0 thickness walls do not work.
Which I will say, especially for my local customers where I kind of know what they're wanting, they give me step models for all the parts they want. I modify the crap out of their models to
Yeah,
I change things on their models all the time. Not just for the manufacturability side of things. So like for example, they'll give me a part and it'll have, a plus 0 minus 15 and it'll be right on that 0 side. And
yeah,
it's like I'm not going to risk going over that. Like I'm going to change that model just a little bit to where like I'm a thou or two, inside that range, that way I don't blow past it on accident. And so like there's a lot of stuff like that where or they'll send me like all the tapped holes. I'll add chamfers to them, or like I'll add if I'm deburring or if I want a part to be fully chamfered on the corners. If I'm doing two ops, so if I'm doing a top view where I'm cutting around the profile and then flipping it over and taking off the top hat, any corners on the parts, I'll add chamfers to those. Even I won't add them on the top edge. I'll just do a manual offset. But when I'm doing the actual walk around profile, I'll add chamfers to all those corners. That way the end mill gets them whenever they're coming around and doing the outer contour. And they do dumb stuff. Like they'll send me parts that have a slot all like a one thing that they're very common about doing is they'll have a part they have a lot of parts that have a 100 thou slot with a hole on one going through it, and then they'll have a bolt that's clamping on it. So it's just a clamp
mm-hmm.
to clamp onto like a tube. And they'll send me one that's like it's 100 thou, and the next time it'll be 90 thou, and then it'll be 60 thou, and then it'll be 80 thou. And I talked to the engineer that I'm in contact with, and every time he's like, "Yeah, that's supposed to be like 100 thou," like. And so I've pretty much standardized that. Anytime I see that on any of their prints, I'll double check with him. But it's like, okay, I'm changing that to 100 thou. Like you got different engineers that are like doing the same thing, but like I'm standard. I have tooling for this. I'm like as long as you're okay with it, I'm standardizing. I'm like any part I see like this is going to be 100 thou. I'll double check with you, but I'm going to be changing it if as long as you're good with it. And so just stuff like that, like I'm getting pretty comfortable where I know their parts and I know what they want. That like I'm learning their standards better than their
Yeah.
designers are learning their own standards. And
And this
so,
is the advantage with working directly with your customer over like Xometry.
yeah.
Because like I could talk to Xometry and be like, can I make this wall thicker? And it would take them, like it would take them a day or two to talk to their customer. And then the customer would take a day or two to get back to them. And then Xometry would take a day or two to get back to me. And all of a sudden, the deadline's passed.
Mm-hmm.
So I don't know. If you want better parts, don't go through Xometry, I guess is the moral of the story here. Talk directly to a machinist.
Yeah.
Uh,
But I have a pretty much a direct line to the main engineer there. At least the engineer that deals with the acquisition of parts. And so I run past stuff to him all the time to the point where we're just texting back and forth throughout the day constantly. We're like, okay, hey, I'm working on this part. Can I change this? Okay, cool. Thanks.
yeah.
So it works out great. And I think that makes for a better relationship with my customer to the point where that constant feedback about things that I'm seeing on their models and their drawings and about stuff that they can change and make revisions to their prints. I don't think they get that from all their shops. And I also kind of feel like that's a service ad to be like, hey, if you sent this to another shop, you might want to change this. Or if the next time you send these parts out, you might want to have this updated or make rev on your drawing. And most of the time, they actually implement a lot of the changes that I recommend. And they're very grateful to get that feedback. So, because they have a they have a lot of problem with a lot of their customers not looking at the prints fully, and
Yeah.
so the problems they're used to dealing with is, oh, we had a part that had tapped holes on 3 out of the 4 sides, and they only did one side, or they didn't do any of them, or they have a tapped hole, they drilled the hole but they didn't tap it, or they didn't add this
Just
feature or that feature.
the dumb mistakes.
Yeah, yeah, which is bound to happen. We had that happen once, and that was just because a customer sent us a 3D SolidWorks file because they knew we had SolidWorks, but we
Mm-hmm.
never opened it in SolidWorks, and so we didn't see we just imported it into Fusion, and Fusion didn't recognize that it was a tapped hole, and it didn't, and so I just drilled the hole, and the customer was like, "Yeah, your part turned out really good." I said, "We just had to tap the hole," and I was like, "What hole? What's that?" And they're like, well, it was in the SolidWorks model. And I was like, oh, I never opened that in SolidWorks. They're like, well, we know you have it. And I was like, well, yeah, but like, I use Fusion to program all my parts. If I don't have to open SolidWorks, I don't. So,
So I'm trying to find a video here so I can. Okay, I found it. This is a change of subject. I'm sorry. Are you okay with the
no, you're good.
subject change?
Yeah, I'm good. I'm good. I'm just meandering.
So I have been trying to find ways to make parts faster. I mean, really, if I want to grow my business right now, it's just I make parts faster. That's the one route that there is. And unlike before, I'm not equipment constrained. I'm metrology constrained in some of the parts that I can take. Like I've seen some funky parts on Xometry that I just don't take because I know I can't measure them. But even if I fix that, it wouldn't really necessarily make me more money. It would just give me some more flexibility. And so really what I realized the other day is that like, hey, I'm the problem. It's me. I'm the reason why I'm not making more parts. And I just like basically as I was going through this kind of thought process, I watched a video that was by the marble machine guy,
Yeah.
Wintergarten, or whatever his name is. Winter Gatan is how it's spelled.
Marble Machine. Just
The
leave
marble
with
machine
Marble
guy.
Machine.
And I have known of that guy for years. I hadn't really watched his videos, but I was, kind of desperate for YouTube videos, so I started watching through those. And he had a video where he was talking about how he had so he did his initial marble machine that everybody has seen. It's got like a billion views on YouTube.
Mm-hmm.
And then he started working on a new design that was more designed for touring with it. And he worked on that design for a while and then kind of realized that design was a failure. And he did a video that like dived into the reasons that marble machine failed. And that video in itself was extremely good and very interesting. That video is called Marble Machine X, A Lesson in Dumb Design. And I highly recommend that everybody watches that video. But that put me down another rabbit hole where another one of the things he said one of the reasons he gave was lack of focus. And I mean, that's something that I know I've been struggling with and something I've been working on for a long time now. And in that, he quoted from a book that was called Deep Work by Cal Newport. And I have been reading that book, and like it's really got me thinking about how I work and how I do things. And basically, the premise of that book, I'm not very far into it yet, but I've only been reading it a couple of days. But basically, the premise of that book is the way that most people work right now is they are in a constant state of distraction with email and social media and all that stuff. And you just don't get nearly as much done. Like you never really develop a mastery of whatever you're working on if you are always working on it in a state of distraction. And I was like, I had already been feeling that. And that's why I, went on the social media break, for example. Like that was before I found this book. But now that I've been reading this book, it's really made me consider the way I work. And I have gotten so much more done when I am actively trying to find ways to focus on my focus, like to get rid of things that are preventing me from focusing. Mm-hmm. So the biggest thing I did, this had the biggest effect, is now when I'm in the shop, the first thing I do is I disconnect my phone from my headphones and I put it on silent and I throw it on the table and I don't look at it. I don't touch it. It's somewhere I generally can't see it in the shop. If I get phone calls, they don't go to my headphones, because that was the source of a lot of distractions. And I'll probably actually put Instagram back on now that I'm like not using my phone in the shop. But what I do instead is I just connected my headphones to my computer, which I get reception everywhere in my shop. And so I can still play audiobooks and podcasts or a YouTube video or whatever. And man, just that one simple thing of not having my phone in my pocket, not having everybody with immediate access to me, I get so much more done. Like legitimately, it's probably the equivalent of 2 or 3 more hours of work more in each day.
Mm-hmm. Yeah.
Yeah. Focus. Turns out it's a good thing when you're trying to make money.
Yep. There's definitely a switch, a mental switch that can be flipped once you get into that workflow state.
Yep.
And I can tell a huge difference in productivity depending on if I'm in that state or not. And sometimes I just struggle to get into it, and sometimes I'm distracted by everything. But I definitely know when I'm in that groove, I don't recognize I'm in that groove until I get out of it, and then I look back and I go, "Oh man, I was getting so much done, and everything was just flowing. I was just in that workflow state." So that's cool.
Yep, it has been helpful. I mean, because there would definitely
go ahead.
Before I really started focusing on focus, there would definitely be days, or sometimes 2 or 3 days in a row, where I would get almost nothing done because I just couldn't focus. Like I would walk in the shop and be like, I am incapable of focusing today. And like I could tell, like it's a thing my brain does that I am aware of sometimes, where I just understand that I'm not going to get anything done that day. And if I was smart, I would just go do something else, like, go do work in the yard or whatever. So I was at least getting something done. And if I wasn't, I would just spend 8 hours banging my head against the wall and still get nothing done. But
in those days when you feel like you're easily distracted, what I've found is even if I know I can't get hard mental work done, like I'm easily distracted, there is still a lot, like the simpler the task, the easier it is to stay focused on it, I've found. So like if I have a hard part I'm trying to program, I need to be in that deep work state. But if I need to clean the shop or set up tooling or clean out the machine or saw material or anything that's less mentally taxing, I can be in that distracted state and still get a lot of work done in those areas. At least that's what I found for me.
So I think this is just kind of an ADD thing for me. And it's even with those things, I would struggle.
Okay.
Like I would struggle to get sawing material done. Yeah. I mean, again, it's probably just an ADD thing going on, or an ADHD thing going on in my brain. I would just not be able to get any work done.
Yep. 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 It happens, and the more you can kind of understand how your brain works, the better you'll get at managing those things. With that said, do you see yourself getting back and posting stories on Instagram at some level? Like is there a balanced state to that where you're not distracted, but you're still engaging with the community?
Yeah, I have missed posting stories and stuff. Like every now and then I'll do something that's kind of cool and be like, this could help somebody. But so I do miss Instagram. I do miss posting stories. Like I got a lot of value out of that as well from like interacting with people, both because it's nice to talk to people and also because people are really smart.
Yep.
And so, yeah, but at the same time, like I have priorities, and if I'm able, like, if it's the difference between making parts and not making parts, I'm going to have to make parts.
Yep.
So I don't know where the balance is there. I don't know if maybe the solution is actually just to do YouTube videos again and to not do Instagram.
Well, I would say just with that thought process alone, it sounds like that's growing up a little bit. Like growing up in terms of like business progression.
Yes.
Uh, because you're figuring out what's important and what needs to be get done and to focus on to grow your business. And as someone who enjoys catching up on your daily stories, and enjoys seeing what's going on in your shop, I definitely understand from someone who's trying to grow his own business how distracting it could be to be posting all of those. So there's definitely a balance there, and I think you're making the right call. So
I'm going in the right direction. I don't know where it's going to end up, but
yeah,
we'll see.
yeah. No, I commend you on that. I miss your stories, and I know there's probably a lot of people that do as well. But at the same point, at the same time, I'm rooting for you, and I'm glad you've made that change. So I like seeing everyone's stories, like of like how it's going in their machining shops. Like I love sitting down for a few minutes and clicking on Instagram and trying to see who's working on what, and if I can glean any information on like how to be a better machinist or learn something new. Um, but I also have a much better a much better appreciation for those shops that like hardly post anything just because they're busy and they're needing work done. Like
Yeah.
they don't have time to show you everything that they're doing. They have jobs, they have responsibilities, and they're there to be a part of the community, but they're not as active as everyone else just because they got so much going on, and that's not as big a priority as getting stuff done for their customer and being a good client for their customer or something.
I will say though, it is something I believe in. It is one of my company values is that like I can look up the exact wording, but it's something along the lines of we move manufacturing forward by openly sharing both our successes and failures, and and let's see, being transparent, showing successes from failures, fostering community, and providing resources. Like that is not just something that I think is kind of cool to do. Like that is actually one of my company values. Is like if the world gets better at manufacturing, the world becomes a better place.
Mm-hmm.
And I'm not going to have a huge effect on that, but if we can get if we can get 10 or 20 shops that removed 5% of the effort from their year by using the salami slice method, like that's a pretty big effect on the world. And
Yeah.
I
Well, here's a thought. Do you get a lot of people that reach out to you during the day when you post your daily stories?
all the time.
So if you started recording your daily stories, but you didn't post them until the end of day,
Yeah.
uh, that might be a way that you can interact with people. But you could have like a dump at the end of the day, and then you have all night into the next morning of people being able to message you. And then during the day, I don't know if you can turn off notifications for Instagram or do something like that. But you can just like, hey, during the day, what type of phone do you got? Is it an iPhone?
Android, OnePlus.
Do they have those? on iPhone, and I haven't messed with it too much, you have the ability to set up like what do they call it?
Like
Your
working hours.
Yeah, working hours or something.
Yeah, I have that. I have basically all notifications turned off on my phone anyway,
Okay.
so that wouldn't make a huge difference. But
Okay. But like if you could like basically anything you wanted to share, you could record it, but just not post it, and then just do a dump at the end of the day or something like that. If you still wanted to, if that would be less distracting, just
yeah,
record it and move on.
I could even just batch message responses to the evening, just like post them and just not respond until the evening.
Yeah,
That would probably help a
yeah,
lot.
yeah.
I I would like to find a way to record videos that isn't distracting at all. I was watching Kurt's videos, Confounded Machine, and the way he does his videos is he basically just records B-roll. Well, I guess it's not B-roll anymore. He records video of just like stuff happening with no voiceover.
Mm-hmm.
Like he's not in front of the camera talking. And
Mm-hmm.
then when he edits his video together, he does voiceover or sometimes a
Yeah.
piece to camera. And I think if I took my DJI camera, for example, and just recorded like a couple snippets of what I was doing, I could do a voiceover at the end of the day, put all the clips together, and I could get a video posted in 20 minutes or whatever,
Mm-hmm.
with very minimal editing and work.
Yeah. Yeah.
And that would, I think, be more valuable than my Instagram stories to people.
Yeah, for sure. And it wouldn't disappear after 24 hours.
And it wouldn't disappear after 24 hours. Though I'd have to be a little bit more careful about what parts I show, but
Yeah. You've done a pretty good job of only showing stuff in process and not showing anything that's like final.
it still scares me the amount that I've shown. But
Yeah. But you've done a pretty good job about I don't think there's a problem with showing parts that you can't tell what they are by the
yeah,
state that they're in. Like if you can tell what a part is, that's when it becomes like really bad, but like if you can't tell what you're making and it's just your machine running and doing roughing operations or something and you can't tell what the part actually looks like, then I don't see an issue with that personally. Other people might, but
well, as long
to
as
me,
Xometry doesn't, it's fine.
yeah, that's the ultimate authority on it for sure. But
did I tell you? So the like cylindrical section parts that I'm doing next. Did I tell you what the file name on those is?
mm-mm.
Reactor casing.
Oh, fun!
It's like, what am I making?
Who knows?
I really hope this isn't part of a nuclear reactor. I assume it's a chemical reactor, but
yeah. Well, just look at this. Sometimes you can glean a little bit of information from the shipping labels.
That's true.
Like I have shipped parts to some pretty big companies, and I'm just like, oh, these parts are going to this company.
Yeah,
that's kind of cool.
About 3/4 of my parts have gone to universities. The other quarter has gone to medical companies.
Yeah, I've had one part go to a space company, and I like to think that part ended up in space.
Yeah.
So
I'm gonna pretend that this part is the parts I'm making are part of a fusion reactor. Yeah. I'm just doing cold fusion over here. That's all.
So that's cool. What else? Did you have anything else on that list that we hadn't hit yet?
The only other thing that I wanted to talk about, and this is probably a whole podcast by itself, is just getting faster. Like,
oh yeah,
how do I make part faster? We talked about the focus thing. That was by far the biggest element of it, but I can spend money on work. Well, I have spent money on work holding. I don't think there's anything new I need that'll help.
You got plenty of tool holders. Like, you're not setting up and tearing down tools constantly, are you?
Yeah, it would be nice to have probably 2 or 3 more, but
okay.
I need more 1/8-inch collets. That's one of my stupid factors right now. I have more tool holders than collets still.
Is pretty much every job you run for Xometry running its own dedicated tooling? Or do you have a library that you're pulling from?
Oh, yeah. So my core tools cover a large majority of what I do. And sometimes I have to buy like a thread mill or a tapper wherever or whatever. But most of the time, I'm not buying more than one or two tools for a job.
Okay. I would say at this point with the work that we're doing, I'm setting up a tool about once every 3 or 4 parts,
Okay.
if that.
Because you have a bunch of
And
them already set up, though.
because I have a bunch of them already set up. And so we're getting to the point where I'm changing them in and out of the tool changer, but they're set up and I just have to plug in the number and swap them out. And that has sped us up so much. It is such a big deal. Makes all the difference in the world. And even the simple act of moving them out of the toolbox and onto the side of the machine where they're visible and I just grab them and go has sped us up because I'm not
Really?
turning around, opening the toolbox, grabbing the tool out. I'll close it. I won't leave it open because I don't want to run into it or back into it or anything. So like opening and closing it while you're changing out the different tools, just like all the extra motion of like turning around and doing everything on that end, just having it where I can literally be looking at both at the same time. I don't know, just like efficient motion has been really nice.
That's good to know. I've been kind of working on solutions for the little ISO 20 tool holders on the Haas. The Right now they're just like in a drawer. But one of the big improvements I did on the Tormach was the tool tags. That made a huge difference in
Mm-hmm.
setting up that machine for me. And so I just the other day I printed out tool tags for the Haas, but like I still don't have any sort of organization for them.
Gotcha.
Basically, I can just write what the tool is on the tool tag, and that's as far as I've gotten. I think I really need to invest in putting tool holder, or excuse me, the tool inventory into my what I call my ERP, the Airtable document that I have. The other day for this peak part, I spent $100. It was like $50 worth of tool and then $50 worth of rush Saturday shipping because I needed it, then. I spent $100 on a tool that I already had.
Oh no.
More specifically, actually, I bought a 183 thou, like 0.183 thou thread
Mm-hmm.
mill from McMaster, but I had
Mm-hmm.
a 0.180 on my shelf, and I just didn't realize that I had it.
Yeah.
So that's $100 that could have been saved by more organization, and I could have gotten the started on the parts earlier.
Yeah.
So I need
Yeah.
something there.
We're getting more and more efficient. Another thing that you don't have a probe yet, but one of the things we're planning on doing at the new Haas is because we will have a wireless probe, and this will become a lot easier. Is we're going to probe in the actual vise and leave that as a dedicated work coordinate offset, and then have our part modeled in approximately the right location on that vise, and then we'll just probe before every operation. And so we won't have to have an offset. We won't have to probe anything in. It'll just be built in. Like that's something I want to build into my templates where I never have to set up a work coordinate system. I just stick my material in my jaws and it's pre-programmed from the get-go. Like that's something I want to build in and that'll greatly speed us up because right now I would say that with having as many tool holders as we have and having all of the parts set up or all the tooling set up, even if it's not in the machine, our biggest time crunch is getting the work coordinate set or changing over the table on the machine. Like if we're going from two vices to the Pearson pallet system to straight on the table or even Saunders vices. So depending on what configuration we want the machine in, that plus finding your work coordinate center is the biggest time crunch.
Yep. Yeah, I have G54 set up as a specific corner on my Flux vise, and G55 is what I use for my Saunders vise, but it kind of floats around. When the self-centering vise gets here, I'm going to set that as like basically the center of the vise,
Mm-hmm.
and the Z will be like the floor, the ledge that the parts sit on. And so that way I will never have to set those two work coordinate systems. And it's only if I have like a third op that I'll need to set something custom.
Yeah. Yeah.
No, I'll have to figure out how to set that center point because it's a virtual point and I don't have a pro, but
yeah.
Probably just probe a 1, 2, 3 block or something.
Yeah. We're having to probe a lot of our stuff right now just because we have we're changing out parallels, or we're changing out where the stop point is or which end's important. And so we're always moving the origin on our parts right now. And if we can get to a point where we don't have to move it and the machine figures it out for us automatically, that'll be a game changer.
Yeah. I don't know if you even need probing necessarily to do it, because you can set it if you standardized on a parallel. You can set the top of that parallel as your Z offset, and then just do the center of your vise, and just always center your stock in there, or do one of the corners of your vise.
Yeah, but there's a lot of times where we have to hang a part off one side of the vise or the other, or we need to grab onto it by such a thin margin that we don't want to do that as our standard. And so there's a lot of specialty cases that we run into, which is why we haven't standardized at this point. But if I had it to where I could get close, I could always just probe it in every single time and just have the machine probe it. So
one thing to keep in mind though is like standards don't have to be perfect. If a standardized workflow works 80% of the time, like that still saves you probably 80% of the work. Like
yeah. No, there's still something to be said. We could still have an origin set up and be using it most of the time. But I would still want to have automated probing some level before I did that, because at this point I'm probing in everything just because I like having my chamfers line up perfectly. So
random off-topic question: did you see an email from me?
An email, maybe.
So I'm not actually sure my new email account is sending emails. It's receiving emails, but it gave me a warning when I sent the email. I'm kind of curious if you got it. But I reworked the Saunders Machine Works thread milling calculator to make it a little bit more sense. Okay, so my email is sending emails. That's good to know.
Okay, yes.
Yeah, I reworked that spreadsheet to, one, just kind of have some better Excel practices. It was surprisingly badly put together, where it like had columns of values that it didn't use, but then it had like the same value hard coded in other columns, like into a formula. And so like I just kind of got rid of some of that stuff, where now it's all like actually using the variables in the columns. And I also added the metric threads in there, so it'll automatically do metric threads. And I added all of my thread mills to that spreadsheet. So now I don't have to go back through and like recalculate it in with the whatever thread mill I'm happening to use. I can just open that spreadsheet and it'll have the the pitch diameter offset right there for all of my thread mills.
Nice.
So I did that like on Sunday. I had a couple hours. I was like, I can go get some stuff done in the shop. And then I went to program a part and I got sidetracked by reworking a spreadsheet.
Yeah. Yeah, I hadn't had a chance to open that up and look at it too closely yet. So I'm still like, last week we didn't really talk about my week last week, but last week was another quote unquote hell week where we averaged between 80 and 100 hours in the shop. And as you can tell, I'm kind of getting over a sickness. And I was sick all last week while working crazy amounts of hours.
Always fun.
Yeah, we had 2 big delivery days, Wednesday and Friday. And we have another delivery tomorrow. And so I'm just about caught up on everything to the point where I'm like not on the edge of a deadline for all my parts that I'm getting done.
That's
and
good.
Then I'll be able to actually relax and catch up on emails and quotes and all the stuff that's been kind of piling up in the background. So, yeah. But big weeks are still nice. Like, I'm as crazy as last week was, I'm hoping that kind of becomes the new normal. Just hopefully I can do it in 40 hours instead of like 100. So, like, I want the workload, just not right now.
Yeah. After the new machine's installed.
After the new machine, that should cut my time down drastically. Like even like, gosh, oh, it's that Tormach. I love it, but you gotta baby it so much to get the part qualities that we're looking for. And so just being able to have a machine cut something and then not have to do two different levels of semi finishing and all this other baby step overs to not have taper, like being able to do that in one pass is going to reduce our cycle times so much.
Yep.
So, and that's just, we just need something to hog material away at this point. Like, and 2 horsepower versus, and ironically, I was looking at this. Everyone says Haas power, as like a joke in the machining world. And, they might rate it at 30 horse, but that's only 30 horse at 200%. I was just looking at the torque chart and the horsepower chart for the Haas with the spindle combo that we're getting. And they rate that at a 30 horsepower machine, but at 200% spindle load and certain RPM ranges, that baby can get up to 45 horse. And so, like, I was kind of surprised by that because I was like, okay, if they're saying it's Haas power at 30 horse and, to people that's 30 horse at 200%, you can only run for a couple seconds or, a couple minutes. Like, I kind of get the joke. But if at 200%, I'm pulling 45 horsepower out of that machine and they're only rating it at 30, then it could probably run at 30 horse day in, day out, or pretty close to it. And you'd be fine. So, I don't know if that's something that they've changed and just Haas had a reputation for that. And like, now they're actually they're running the opposite end on their specs. Like they're under claiming what it was, or they're claiming the same value, but they're just increasing the motors. But I just thought that was interesting. I don't know if anyone else has actually looked at that or noticed that, but I thought that was kind of cool. So also, remember when we talked about the taps, and did we talk about taps and like running a big tap in the Tormach the Tormach versus Haas versus like Mazak? So I did a little more digging because I went back in that Wayback Machine to see what the old Mini Mills torque spec call out was, and the old Mini Mills was only 22 foot pounds, or sorry, 22 or I think it was 22. I think they were only rated at like 22 foot pounds of torque, whereas the new ones are rated at 45 foot pounds of torque, and the Haas that we're getting is rated at 95 foot pounds of torque.
Gosh.
And so, and then the Mazaks that I was able to find that were similar to the shop here that says they were having a hard time turning big taps before. I couldn't find the torque horsepower curve, but they were rated at like 40 or 50 foot pounds of torque. So the Haas is almost double that.
But
that's still a lot larger than the Mini Mill, and they were telling me that was at a size where their machine might start to struggle. Their Mazak.
They may just not be willing to push it all the way, or
maybe, I'm not sure.
Some machinists are more conservative than others.
Maybe, but they say it like actually stalls out their machines, so that's just what's confusing me.
Yeah, that may just be what they think.
That or they have newer Mazaks. I wonder if they had older Mazaks and then when the older Mazaks maybe had less power, and then when they upgraded it, they assumed it was going to be around the same. But they also have, I think their Mazaks are 15K, and so I'm wondering if they got a higher spindle rated, higher RPM spindle, and so it doesn't have as much torque at the low end, which could be the other side of that equation. Because our Haas is only going to be a 12,000, and I haven't looked at the 15,000 spindle for the VF. I did look at the Mini Mills. The one thing I did notice is that the new Mini Mills have a 8,000 RPM spindle, and the old ones had a 6,000, and you can upgrade it to a 10,000. So this was interesting. The old one, 6,000, was rated at... Oh, no, that's what it was. The old one at 6,000 was rated at 30 foot-pounds of torque. The new one is 45 at 8,000, but if you go to a 10,000, it's only rated at 22 foot-pounds of torque.
Interesting.
Yeah, I'm throwing a lot of numbers.
Yeah,
we could probably boring a lot of people, but I found
it's
all
late
these
in the
numbers
podcast. We can start doing math.
I found this very fascinating, like how the torque power curves and all that kind of was meshing with the RPMs of the machines. Anyway,
a couple clerical notes here before I play the music. This is the 11th of December when we're recording this. The week of Christmas, so that's, well, you know when Christmas is. And the week after that, which is the week of New Year's, we were not going to be recording an episode. There will be 2 weeks off. Yes, we did not record an episode last week because I was very frustrated with peak parts on Monday, and then Harrison was sick later in the week, and I think very busy. So we are not recording, or we are recording next week. We are not recording the week after or the week after that. We're still fine. We're still breathing. It's okay. Also, don't forget that we now have a Patreon. If you want to support us and help get us to IMTS in 2024, patreon.com/tapsandpatience, or link in the description right next to our very beautifully AI-generated transcript, or not transcript, summary.
What do you think about for the last podcast doing like a end of year summary, like just going over everything that's happened this year and talking about how we've kind of grown from beginning to now?
I like that. We could do that. I feel like a shocking amount has happened in the last year.
Yeah. Yep. So we should go listen back. Oh, interrupted my thought. All right. We'll talk about it another time. Thank you guys for hanging out and listening to the Taps and Patience podcast with us. We appreciate you guys hanging out, and I love hearing from you guys whenever you reach out and tell us your thoughts on what you heard. So please like, share, and tell all your friends. And yeah, so thanks for listening and hanging out. I'm Harrison with Precision Ingenuity, and I'm here with AJ from Audacity Micro.
I was watching a video. I think it was like a food theory video or like game theory. It was one of those. I don't know. Mm-hmm. It was a bigger YouTuber, and they used our song in their video.
Oh, they did?
They did. How dare they?